All right, so this will be our last lesson, and we're going to be focusing on interval testing. So notice last lesson with the absolute value inequalities, we tested those via interval testing. So we're going to look at that today with quadratics and rational inequalities. So we're going to solve these, we're going to do them graphically, and we're also going to do them algebraically. And I want to define this idea of a critical value. So critical values are really important when we get to calculus. So let's kind of introduce this idea here. So if we are looking at a critical value, critical values are going to be numbers that solve the corresponding equation. So I'm going to convert this inequality into an equation. So either a number that solves it or a number that makes our function undefined. So for example, if we're dividing by 0 somewhere, that number would be considered a critical value. So let's take a look at this quadratic inequality. So nothing crazy about it. Pretty typical. Notice it's already kind of set equal to 0 here, and I guess not really set equal because it is an inequality sign. But what I'm going to do is, because we have every single term on one side and 0 on the other side, we are going to work with the corresponding equation. So we're going to solve this quadratic. So again, you could do quadratic formula, you could complete the square, you could try factoring. If I could multiply to -3 and add to -2, which I think I can, I would rather solve it via factoring just because I'm a little faster at it. So I end up with this, and going ahead and solving, I'm going to get -1 and +3 for my possible, or I guess for in this case, my critical values. So let's go ahead and label those critical values. We'll call those CV for critical values. So we are going to use these critical values on our number line. So the only two numbers I'm going to put on this number line are going to be my critical values. Now, like we did with the absolute value, we are going to test the 3 intervals that we have set up here. So I need to test a number that's going to be smaller than -1. So for example, why don't we test x equals -2? This is going to go back up into the original inequality. You could also use the factored version, which sometimes I tend to do because I'm a little bit faster working with my values in the factored form. I do need to put my inequality sign here, so I need to have negative numbers on this left-hand side. So what I'm looking at here is -2 minus 3, that's a -5. -2 plus 1 is -1. So is a negative times a negative going to be smaller than 0? That answer is no, because that's a +5, and 5 is not less than 0. So that tells me that this part of my interval does not work. So let's look in the middle part. So I need to pick a number between -1 and 3 to test. So let's test 0. So what I'm going to do is I'm going to go back to that factored version, because again, I'm a little faster there. And I'm going to see if I plug in 0 for x, if I am going to be less than or equal to 0. Again, I'm getting that from up here. So is -3 times 1 less than 0? And that answer is yes, because a -3 is less than 0. So that tells me that this interval works. So I'm going to go ahead and let's highlight that guy for right now. And let's test the last one. So I'm going to pick something bigger than 3, so let's pick 4. And this will be our last test because that's our last interval that we need to look at. So 4 minus 3 is 1, 4 plus 1 is 5. Is 5 less than 0? No. So that interval doesn't work either. So that tells me all the numbers between -1 and 3 are going to work. Now I'm going to look at what kind of endpoints I'm going to have. This is just a less than. So that tells me that those will not be included. The other thing I need to look at here is I don't have any undefined values. I'm not dividing by 0 anywhere, and I don't have anything that makes, my function undefined. So those numbers are all okay to be included within this interval. So we would say our solution would be between -1 and +3, not inclusive. Now let's look at this graphically. So here's a picture. So this dashed line right here represents my quadratic inequality, x squared minus 2x minus 3. And then notice we are looking for numbers that are going to be less than 0. So less than 0 means my y values are going to be negative. So I want to look at all my y values that are down here. So what x values correspond to my y values being less than 0? Well, my x's from -1 to +3, where those x-intercepts are. So that's kind of graphically how we can approach these problems as well. Let's take the same problem, but let's just switch up the inequality sign. So same picture right here, same inequality. This first one now is going to be less than or equal to 0. So that means I'm going to include those endpoints on here. So all that does to change it is it would now be -1 to +3 inclusive on both of those. If I want greater than 0, so I'm going to clean that up. If I want greater than 0, now I'm looking at my y values that are positive. So that means I'm looking at these two individual pieces here of my graph. And since it's just greater than, I just did that to highlight it. Since it's just greater than 0, I'm not including those endpoints. So that tells me when x is between -infinity and -1, not inclusive, and then skipping over and then joining in with 3 to infinity, those are my intervals of x's where my y values are positive. And then so then the only change for this third one down here would be we would be including the endpoints. So that's just kind of an idea on how to do it graphically, and it's the inequality sign that doesn't really matter. We just need to pay attention if we're including or excluding those values, and then what values work to make the interval true. So let's check out another one. This one's just a little bit more intense because the numbers are just a little bit bigger. So this one is going to make me work because notice we don't have 0 on one side of the inequality. So we need to start by doing that. So I'm going to go ahead and add the 2x over. So -3x plus 2x is -x. And then I'm also going to subtract the 10. And then that would be greater than or equal to 0. So let's try to factor this. I don't have a GCF that I can take out. If you don't want to factor, you're welcome to use quadratic formula here. So my little shortcut method to factor is I want to multiply to the a term times the c term. So 3 times -10. My goal is to multiply to -30. And I want to add to the b term. So I want to add to a -1. So you need to find those two numbers. I think it's going to be a -6 and a +5. That will multiply to -30 and add to -1. Now, the shortcut here, and this is what makes this process so nice, is you want to put the a value up top. So my a value for this problem is 3. And I'm just setting up these two ratios right here. Now, if I can reduce the ratio, I want to reduce it. So 3 over -6 would reduce to 1 over -2. Notice I'm keeping that negative sign with the 2. And then 3/5, I can't do any reducing there. So these are actually going to be my two quantities. I'm going to have x minus 2 for one, and I'm going to have 3x plus 5 for the other one. And then notice I'm going to set that equal to 0 because my goal is to solve the corresponding equation. Now that it's factored, we can go ahead and do that. So that tells me that x is going to be +2 or x is going to be a -5/3. So those are my two critical values because those are my two solutions to the equation. So let's find those numbers on the number line. Again, I'm not being worried at all like where those numbers really fall in the number line. I'm just setting it up so I can see what my three intervals are going to be. So now test a number that falls within each interval. So if that's -5/3 right there, let's be crazy and maybe test x equals -2, because that would be slightly smaller than -5/3. So I would go up and I would test it. Again, I'm quicker with the quantities here. And just remember, I do need to, in this case, put my inequality sign back in because I'm going to see if I'm going to get a true statement here. So let's plug in -2. Is -2 minus 2 times 3 times -2 plus 5, is that going to yield a positive answer? So I've got a -4 times, let's see, that's -6 plus 5 is -1. That's going to be yes, because that's going to be +4, which most definitely is greater than 0. So that interval works. So move on, let's do the middle interval. Always want to pick 0. That's my easiest one ever to test. So let's do that one in the middle because that's where 0 falls. And let's plug it in. So that's going to give me is -2 times, I guess that would just be +5. Is that greater than or equal to 0? And that answer is no, because a negative number is not bigger than 0. So that one gets the boot. And let's try the last one. So let's be, I don't know, crazy, and let's test, say, 3. So is 3 minus 2 times 3 plus 5, is that greater than or equal to 0? So that's going to be +1, and this is going to be something positive, whatever it looks like, 14. And 1 times 14 is definitely greater than 0. So that tells me the two outside intervals are going to be my solution. So from here to infinity, and from there to -infinity. When I write my answer here, I do need to make sure I pay attention to the endpoints. Again, the -5/3 and the 2, they are not a value that makes my domain undefined. They are simply the solutions to this quadratic inequality. So that means since I have a greater than or equal to with my inequality, that both of these are going to be included because both of those are solutions. So I'm looking at -infinity to -5/3 inclusive union 2 to +infinity. All right, let's look at the rational ones. So these are going to be the fractions. These ones are probably going to cause you the most work because we do have to do some manipulation with some of the fractions, as well as we are going to get some values here that are going to be undefined for our critical values. So this one, notice it's not, we don't have 0 on one side. So we do need to take a moment and we need to bring that 3 over. So I'm going to go ahead and subtract 3 from both sides. And now I need to do some fraction work. I'm actually going to give myself a little bit of space here, just because I am limited being on the iPad working this. So if I'm subtracting 3 on that side, I need to get a common denominator because I do need to get this down to just one fraction on this left-hand side. So if this is really 3/1, I'm going to multiply both top and bottom by my common denominator. In this case, it's going to be x minus 5. And let's see what happens. We're going to get 2x minus 7 all over x minus 5. And then I am subtracting this entire right-hand quantity right here. So I am going to go through and add the opposite because I need to make sure I'm keeping track of my signs. So I'm going to do plus a negative there. So that means I'm distributing a -3. So I'm going to have plus a -3x and then plus a +15 all over x minus 5. Now that I have a common denominator, I can simply clean up the numerator. So 2x plus -3x is a -1x, and -7 plus 15 is 8. So I'm going to end up with something that looks like this. So this is my goal. It's not pretty, but this is what we're going to work with. So when we identify our critical values here, remember, critical values either solve the equation or they make the function undefined. So what would solve our equation would be what would make this numerator 0, because it doesn't matter what's on bottom, 0. Actually, let me write the corresponding equation here. What we're really solving here is -x plus 8 all over x minus 5 equals 0. So when I'm looking for these critical values, the number that solves it would be whatever makes the top 0, because I have 0 divided by whatever, that will always be 0. So what could I plug in up top to make 0? Well, it looks like +8. And if you're ever not sure, just off to the side up here, you could always take that numerator and set it equal to 0 and then solve the equation. So I'm going to go ahead and add x to both sides. So if you have a more complicated numerator, just set it equal to 0 and then solve it for x. So I'm going to have a critical value at +8. And then my other critical value will be what makes my function undefined. Since I have a value in the denominator, that means I have a chance of dividing by 0. So if x were equal to +5, I would have a big issue because now I'm dividing by 0. So that makes 5 a critical value as well. So I'm going to set up my number line with 5 and 8. Now we're going to do the interval testing to see what values are going to work here. So let's pick something that's going to be to the left of 5, so say 0. And let's go ahead and plug in 0. You can plug it back into this simplified inequality here. So if I plug in 0, that's going to leave me with 8 on top and negative 5 on bottom. And so that's a negative number, which most definitely is less than 0. So that interval on the left works. All right, let's test something between 5 and 8. So let's test, for example, 6. So let's plug in 6. Negative 6 plus 8 is 2. And then 6 minus 5 is 1. So is 2 over 1 less than or equal to 0? No, because that's a positive value. So that's a no, so that one gets the boot. And then let's test something bigger than 8. So let's test maybe 9. So negative 9 plus 8 is negative 1. And 9 minus 5 is 4. Is negative 1 divided by 4 less than or equal to 0? It is. So that's going to work as well. So this helps me determine my intervals. Now, since we do have values that make our denominator undefined, even though this inequality says less than or equal to, I can't include 5 in my solution. So, whoops, I didn't mean to do it like that. Because it means I'm dividing by 0. So that is going to be an open parenthesis on the 5. Even though that's less than or equal to, I cannot include 5 because it's not a part of the domain of my function. 8 is, because 8 was a solution to it. So this is where I'm looking up here to be like, hey, do I include it or don't include it? I do, because it's a solution. So my answer here will be from negative infinity to 5, not included, union 8 to positive infinity. Now, if we look at this picture is actually this graph right here. It is not the original problem. It's our simplified version, so that way we have it so we can compare it to y equals 0. So we are looking for values that are less than or equal to 0. So notice that's happening here. We have our values dip below, and then notice all of these values up until our vertical asymptote right here. We do have that vertical asymptote at x equals 5. So every x value to the left of that yields a y value that is less than 0. All right, here's my last example for you. So this one's a bit of a gift because you already have a 0 on the right-hand side, so that's really, really nice. So let's go ahead and solve this. Looks like the numerator could be factored. We need to multiply to negative 8 and add to negative 2. So I think negative 4 and positive 2. And then that puts x minus 1 still down below. Now that it's factored, we can quickly come up with our critical values. Because my two solutions, again, the solutions would be what makes the top 0. So what makes 0 up here? Well, positive 4 would make 0 inside of this first quantity, and negative 2 would make 0 inside of the second quantity. So we're going to have a critical value at positive 4 and at negative 2. That comes from the numerator. And then we'll have a critical value as well for whatever makes our function undefined. So we're going to have a critical value here at positive 1. So when I set up my number line, this will be the first time we have a lot of values on our number line here. So we're going to have negative 2. And again, I'm just putting these in order. I don't really care a whole lot about the spacing. I'm just using it as a guide to help me determine my test values here. So I'm actually going to have 4 things to test this time. So I need to test something that's going to be to the left of negative 2. So let's maybe test x equals negative 3. And again, I'm a fan of plugging it into my factored version. A lot of times I'm just looking at the signs. So negative 3 minus 4, I'm just thinking to myself, okay, that's going to be a negative. And then I have negative 3 plus 2, that's going to be a negative. So a negative times a negative yields a positive up top. And then on bottom, we have negative 3 minus 1. That's going to yield a negative. So this gives me a positive divided by a negative, which is not greater than or equal to 0. So this interval doesn't work. So let's move on. Let's test the next one. Between negative 2 and 1, why don't we test x equals 0? I love testing 0. So easy to work with. So that gives me negative 4 times 2 all over negative 1. And is that greater than or equal to 0? So that's a negative up top and a negative on bottom. So a negative divided by a negative is a positive. Positives are bigger than 0. So that interval works. Let's keep going. Between 1 and 4, How about we test 2? And here we go. So 2 minus 4 gives me, it looks like -6. Nope. Gives me -2. 2 plus 2 is 4, and 2 minus 1 is 1. So this is going to be a negative up top and a positive on bottom. So that's going to be overall a negative number. Negatives are not bigger than 0, so that interval doesn't work. And let's test our last one. So something bigger than 4. How about we test x equals 5? 5 minus 4 is 1. 5 plus 2 is 7. And 5 minus 1 is 4. All of these are positive numbers. So positive times a positive and then divided by a positive will still be positive. So that tells me that this interval right here works. So my solution to this equation then is going to fall. It's going to be here between -2 and 1, and then it's going to be bigger than 4. Now to keep track of our values, this does say greater than or equal to right here, but remember our critical value of 1 makes our function undefined. So even though 1 is a critical value here, and I do have the greater than or equal to, I need to not include it in my answer because it makes my function undefined. So everything else will be the closed parenthesis, except at the 1, because my function's undefined there. So from -2 to 1, and then from 4 to infinity inclusive. All right, homework. Your last homework assignment will be Connect Math on interval testing. Again, please let me know if you have any questions, and thank you all for the great semester. Visit me during office hours this week for any questions that you guys have, or just let me know if that doesn't work and we can set up a mutually